I welcome you to this video, and today I'm going to tackle advanced writing and balancing chemical equations. Advanced writing and balancing chemical equations. And before we dig deep, I'm going to talk about writing chemical equations in a funny way or in a unique way. The first key thing that I'm going to handle is something known as radical. Something known as radical. And I want you to be very attentive in this video because we are now going to handle writing and balancing chemical equations in an advanced way. Now, radicals. What are they? Because sometimes you may hear people talk about radicals. Some don't know what radicals mean. Now, in this video, I'm going to explain that. Radicals are sometimes called free radicals. Free radicals. Or sometimes we can just simply call them radicals. So what are they? Now, radicals are, or we can call it, is an atom, comma, or a molecule or ion that has at least one or more unpaired, has at least one or more unpaired valence electrons. This is the definition of what radicals or radical is. In other words, I can define a radical as a group of atoms that react with a unit charge. Is a group of atom, or let me add something here, it can be is a group of atoms or atom, yeah, that's key, that react with the unit charge. Now, if they are having a charge, the keyword here is charge. Now, I can now go ahead and analyze radicals based on their charges. Now, I want now to analyze radicals based on their charges. So, a charge is added on an atom or group of atoms. Now, I can have first stage is first stage I'm going to talk about radicals with valence 1, and such radicals are sometimes known as, can even call them monovalent radicals. Monovalent radicals. Now, examples of such radicals, there are so many, and I'm going to handle all of them and go ahead and even discuss a chemical reaction involving them. Example of a monovalent radical is hydroxide. My first example is hydroxide. Hydroxide, OH minus. Number 2 is nitrate. Nitrate, written as NO3, the minus on top. Number 3, I'm going to have nitrite. Nitrite, NO2, the minus. And our fourth example of monovalent radicals, or of radicals with valency 1, we can have hydrogen, sulfate, or we can sometimes call it bisulfate. Bisulfate. And all these we always write them as HSO4, HO4 minus 1, the minus on top. Number 5 is bisulfite, or hydrogen sulfite. And we always write it as HSO3, the minus. That's our number 5. Number 6, we have hydrogen carbonate. Hydrogen carbonate, HCO3 with a minus. Then I can have acetate. Number 7 is acetate. You'll meet this in your advanced chemistry A levels. We'll talk about it, or we will even talk about it when we'll be handling organic chemistry. CH3COO minus, that's acetate. And lastly, our number 8 is permanganate. Permanganate, written as M, capital M, N, O, the minus. All these are examples of monovalent radicals. Why am I discussing this? Or why have I decided to talk about this under writing and balancing chemical equations? Most compounds that we have in the lab are not pure elements compounds. So sometimes you can have a compound reacting with another compound to give us another compound. Most chemical reactions we do in the lab are either metals, which are always in pure form, or as compounds. So I wanted to talk about this so that you can know that there is an advanced way of writing and balancing chemical equation other than just picking elements from the periodic table. So that's what we are going to talk about here. Now, I'm going to pick these radicals by themselves and trying to come up with chemical reactions that we can use to understand them further in chemistry. Now, anhydroxide, the OH minus, is a unique type of radical, very unique, because it is something that constitutes the bases. So meaning I can have an element reacting with a base to give me another compound. So I want to try writing chemical reactions between group 1, group 2, and group 3 metals with hydroxide, because if you check very well, you realize that hydroxide have a negative charge on top. So it can behave as a non-metal. So in this video, I'm going to talk about reactions involving hydroxide with group 1, group 2, and group 3 elements. Now, for example, in group 1, I'll pick lithium, solid, reacting with hydroxide. What am I going to form? The same way I said initially, we're going to have a situation whereby now lithium, let me break it down. Lithium will now have Li positive reacting with OH minus. Then they'll interchange their valence. Then what are we going to form? We are going to form LiOH. LiOH. Now, that's what I'm going to write as my product. And now, when I come to my product side, I'm simply going to pick whatever thing I want to deal with. And now, I'll simply erase this area because I want to have a neat work. I'll simply erase this part because I now don't need it. I was just explaining the concept. Now I'm going to have LiOH, lithium hydroxide. So these are solid. This is always in aqueous state. This still aqueous state. Now, there is no need to balance. There's no need for balancing because I only have one lithium, one hydroxide, one lithium, one hydroxide. Can go ahead and do another example using sodium. Can bring in Na, solid, plus OH minus. The same thing because they are all elements in the group 1. I'm going to have NaOH, aqueous, and this is a solid. There's no need for balancing because I have one sodium, one hydroxide, one sodium, one hydroxide on the product side. So that's it. Now, the next thing that I'm going to do, I'm going to erase this part, and now we are going to analyze reactions of hydroxides with group 2 elements. Reactions of hydroxides with the group 2 elements. So let us see. Let me pick a group 2. A group 2, I can have calcium and magnesium. So let me start with magnesium. Mg, solid, plus OH minus. What am I going to form? I'm going to form stationary by, let me break it down also so that we know what we are dealing with in each and every stage. Magnesium is in group 2, so it will have a 2 positive on top plus OH minus. When they interchange their valences, what will happen? A 2 comes here, a 1 minus goes there. Then what do we form? I'm going to form Mg into bracket OH2. Why? Because magnesium is losing 2 electrons and hydroxide only needs 1 electron. So I need 2 hydroxides, 2 of them, to accept each electron from magnesium for this to be stable. So that's what I'm going to have at the end of the day. And I'm going to erase that 2 after erasing it so that I can begin with a nice space which I can work. So I'm going to erase this because I don't need it now. I don't need it. And now I'm going to have my product, which is mg into bracket oh 2 aqueous, and this is still aqueous. That was a solid. It needs balancing. Why? Because mg is 1 here, mg is 1, hydroxides are 2, hydroxide is a 1 here. So what do I have to do? I simply have to put a 2 here. So I'll simply put a 2 here to ensure that it is balanced. Then we call it a well balanced chemical equation. I can go ahead and do with calcium. Another example with calcium, OH minus. Then what am I going to have at the end of the day? The same, because they are all in group 2. I'm still just going to have calcium 2 positive plus OH minus. Then they interchange their valencies. Then at the end of the day, I'm going to have calcium into bracket OH 2. Then that's what I'm going to have. That's what I'm coming to write here. So when I bring it, I'm writing calcium OH into bracket 2 aqueous. But majorly, sometimes it is a solid. You have to be careful because calcium hydroxide is a precipitate. So majorly, we go with a solid. It's a concept that's always used. So you should always know that. But regardless of the syllabus you are undertaking, it can either be aqueous or calcium is partially soluble. So sometimes you can form aqueous or sometimes solid. You have to be very careful with the kind of your syllabus specifications when handling that. I don't want to go deep into it because I don't know the kind of syllabus specifications you're handling. So as a student, you really need to be careful with that. Thank you. Now, I've handled group 2. Now, I can go ahead and try it with a group 3. No, sorry, I haven't balanced. I haven't balanced it yet. Sorry for that noise in the background. I haven't balanced it yet. So let me do the balancing. If I do the balancing, you'll come and realize that hydroxides are true, the same, because they're all in the same chemical family and they're all in group 2. I'll simply put a 2 here to ensure that my chemical equation is properly balanced. Then I can go ahead and do another one. With group 3, and the example I'm going to use here is aluminium, which sometimes can be asked. So I can have any of group 3, can have aluminium solid reacting with hydroxide. Then what product am I going to form? I'll simply bring Al, the 3 positive, plus OH minus, then they interchange. So I'm going to have Al taking 1, then we have in bracket OH, then 3. This is what we're going to put here. Then I'm going to have Al into bracket OH, then 3. If in a situation whereby now it is reacting with any of group 3, I was using aluminium as an example, and that's what we can form if we use aluminium as our example. So anytime an hydroxide of valency 1 or a monovalent substance is reacting with a group 3 element, we are going to form that, and that's what we are going to form at the end of the day. That's a very nice example of group 3. So that's just an example. Now I can go ahead back again and pick another substance that I can use. I can use even a nitrate, but in this scenario I'll use any of this to show you. Now in the remaining examples of monovalent radicals, I'm just going to use one example at a time so that we don't consume a lot of time in that given area. I'm going to use one at a time so that we don't spend a lot of time on it, because it is an easy concept. Now I can go ahead again and rub this. So after rubbing it, I'll simply come back. Then the next one that I'm going to handle is nitrate. Nitrate is NO3 minus. And there is another thing that I want to say after writing that example. So the next one is nitrate. My next example is nitrate. Nitrate NO3 minus. Now I can have group 1, group 2, group 3 reacting with it. Group 1, I'm going to start with sodium, solid, plus NO3 minus. What am I going to form? I'm going to form NaNO3 aqueous solid. Then I want to pick a group 2, Mg, solid, plus NO3 minus. What am I going to form? I'm going to form Mg into bracket NO3, close the bracket with a 2. Then can go ahead and have a group 3, which is aluminium solid. Sorry, this was aqueous. Plus NO3 minus. What do we form? I'm forming Al into bracket NO3 aqueous. That was when we are dealing with nitrates. That's when we are dealing with the nitrates. So it becomes very easy and simple to write chemical reactions. And now I'm going to the next stage, where I'm going to pick another monovalent radical and see how we can react with the first 2, 3. The next one that I'm going to pick, I'm just going to pick randomly. Let me pick hydrogen sulfate. When I bring in hydrogen sulfate, I can use hydrogen sulfate as my example. I'm just picking samples. Hydrogen sulfate. So hydrogen sulfate as my example, which is called bisulfate. Bisulfate. Now, when I bring a group 1, lithium, Li, solid, plus hydrogen sulfate minus, what am I going to form? They are going to interchange their valencies. So at the end of the day, I'm going to have lithium, Li, H, SO4, aqueous solid. If I bring a group 2, I can have calcium solid, plus bisulfate, then I put a minus there. At the end of the day, I'm going to have calcium hydrogen sulfate at the end of the day. Sorry, there is no charge. Then we have our aqueous at the end of the day. Then this one is also aqueous. The same also applies if you bring a group 3 element. Then I'm having Al solid plus H SO4 minus. The same is going to repeat itself. We are going to have Al. Then in bracket is going to be, sorry, there's something that I missed. There's something that I missed here. There's something that I missed. There's something that I really missed. Let me clear it out very well. There's something that I missed. I did not take into consideration the valencies. And now, when that happens, now remember calcium is in group 2. So if calcium is in group 2, what will happen is calcium 2 plus H SO4 minus. When they interchange, 2 comes this side, 1 comes here. So at the end of the day, what are we going to form? We're going to form Ca into bracket H SO4. Yeah. with the 2. That's what we must form at the end of the day. So that's what I'm coming to write here on top. Sorry, I missed that. I really missed that. Yeah, let me correct it. It's corrected now. It's now corrected. And now I'm coming here to correct it. And now I'm going to have my Ca to bracket H SO4 to the 2 aqueous. Yeah, that's the product. The same is going to apply here. This still aqueous. Then I'm going to have into bracket H SO4 3 aqueous. The reason why I'm doing this, just want you to be careful on the valencies. That's why I'm picking this. I want you to be careful. Al is supposed to be 3 positive when it reacts with hydrogen sulfate. Sorry. What will happen? They are supposed to interchange their valencies and charges. This is -1, 1 minus, and this is plus. When they do so, that's when I'm going to form this substance here. Because now Al is going to pick 1 and HSO4 is supposed to pick 3. Now we put this in bracket and put a 3 here, sorry, a 3. That's what we're supposed to be having at the end of the day. So that's how we can have radicals of valency 1 or monovalent radicals going through reactions with different metals. And lastly, let me say something under this. Most of these monovalent radicals doesn't exist in nature, but they exist in form of compounds. They exist in form of compounds, and we will discuss that when we will be undertaking reactivity series, a concept that is taught in O-level syllabus, both Cambridge and Pearson, and any kind of examining body. All of them talks about that, and I'll be handling that when I'll be talking about reactivity series of elements. Now, the key thing that I want you to understand is most of the time in nature, we cannot find hydroxide on its own, but we'll find it reacted with another element. So I can have zinc hydroxide react with sodium. I can have sodium hydroxide react with potassium. Now, based on their ease within which they react or based on their reactivity, we'll come and analyze how they can react and what type of products will be formed. But as for now, I just wanted you to know that radicals exist, and when they are reacted, it's just a direct type of reaction. So in nature, let me just clear that out. In nature, most of the time in our labs, you'll come and realize that in our labs, we have no hydrogen sulfate. But what we have is, we have either sodium hydrogen sulfate, which is written as NaHSO4. This is now found in our lab as a compound. But we don't have hydrogen sulfate on its own. I can have magnesium hydrogen, I can have magnesium hydrogen sulfate in the lab. Okay, so meaning I can react this with a more reactive element, then I will have a given product that I'm interested in. So different types of radicals or monovalent radicals can be found in our labs or in different areas in life as compounds when reacted with other metals. That's what I wanted to say as far as monovalent compounds or monovalent radicals are concerned. The next thing that I want us to handle is now the bivalent radicals, and I'm going to do a quick example, and we are going to see how these different types of radicals can be used in writing and balancing chemical equations. It's a very easy concept, but it can become tiresome when you don't have a good ground of understanding and also analyzing them. That's why I've taken this opportunity to enable you understand and know that different types of compound exist and we have different types of radicals. Now, in the next step of this discussion, I want us now to analyze bivalent or radicals of valency 2. I have radicals of valency 2, or we call them bivalent, bivalent radicals. Bivalent radicals. Yeah, we call them bivalent radicals. And I have variety of examples. Just to minimize space. Variety of examples that I have. The first one is sulfite, which is SO3 2 minus. I have sulfate SO4 2 minus. I can also have carbonate, which is CO3 2 minus. I can also have chromate, which is Cr. It is a CrO4 2 minus. I can also have dichromate, which is Cr2. Oh, sorry, these are 2 or 7 2 minus. I can also have manganate. As another example. Manganate, which is, in terms of symbol, we write it MnO4 2 minus. So when that happens, now we can do example of reaction involving this with either group 1, 2, 3 elements. Now, in a situation whereby I can use sodium, I'm going to pick variety of examples. I can have sodium, Na, solid, reacting with sulfate, SO4 2 minus. Because sodium is in group 1, sulfate has 2 minus, they'll interchange. So at the end of the day, what I'm going to have is simply a type of reaction where Na, the positive charge on top, and SO4, the 2 minus, they are simply going to interchange their valencies. When that happens, when they interchange the valencies, and charges, now I'm going to have Na to SO4. So that's what I'm coming to write on top of my chemical equation here. So I'm going to have Na to SO4. Now you realize that N is a 2 and you can balance it, and that's what you are going to form at the end of the day. Let me even go ahead and have chromium or chromate reacting with the potassium. Let me have K, potassium solid, reacting with Cr. Then chromate is CrO4 2 minus, CrO4 2 minus. Then what am I going to have? Remember, this one has a positive charge on top when they interchange. Sorry, I just want to remove that because it is not necessary here. Now, when that happens, what am I going to have? I'm going to have K2CrO4, which is now potassium chromate. This is the substance that I'm going to form at the end of the day. Then I simply put a 2 here to ensure that potassium is balanced. So that's the type of reaction that can occur when various type of bivalent radicals react with different type of elements from the periodic table. Then you can go ahead and try for group 2. I'm going to do one for group 2 so that you can use it as your example, or you can follow. I'm going to have Mg solid reacting with any, let me pick any dichromate, but mostly it doesn't react with dichromate. Let me take sulfite. COSO3 2 minus, then I'm going to have Mg, because it is a group 2, both have 2 SO3. Then this is what I'm going to form at the end of the day, and the equation is balanced. So this is aqueous, this is still more of aqueous. Then that's what we are going to have at the end of the day. So that's the knowledge that we can have as far as radicals of valency 2 or bivalent radicals are concerned, and how different types of elements can react with this to give us different types of products. So I'm going to the last stage, where I'm going to handle radicals of valency 3. So I want to handle radicals of valency 3 so that we can also see examples involving that. In chemistry, you really have to know these things. In chemistry, you really have to know them. Yeah, because if you don't know them, you'll really have problems in chemistry. Writing and balancing chemical reactions, involving direct elements from the periodic table, involving diatomic elements, involving given elements and radicals, you really need to know them. Because as we are going to further our studies in chemistry, there are certain reactions that involve exchange of radicals. I'm going to do a sample of that at the end of the video, and you're going to see what is really happening. Now, I'm having now radicals of valency 3, which we call trivalent. Now I'm having radicals, sorry, I'm supposed to use a different color to bring consistency in my writing. Now I'm having radicals of valence 3, or trivalent radicals, that's what we have. They're very simple. It involves all elements in group 5 in the periodic table. So elements in group 5 of the periodic table, they're trivalent because they have a charge of 3 minus. So example, here we have nitrogen, which most of the time forms 3 minus, which is known as nitride. So when we have a nitride reacting with any element, let me bring an example, and I'm going to do a variety of them. I can have lithium solid reacting with N3 minus. What do we form? I'm going to form Li. What will happen? A 3 will come below lithium, and N is going to be 1. Then I'm going to form lithium nitride. Then how do I balance it? I simply put a 3 here. So this is an ion in aqueous, this is solid most of the time. Now I'm going to do a group 2, where I'm going to pick calcium. I'm going to pick calcium Ca solid plus N3 minus. Then calcium is a group 2, nitride is a group 3. So what is going to happen? Calcium is going to pick the 3, nitride is going to take the 2. So when that happens, I'm going to have this, because it is an ion, this is a solid. So what is going to happen here? I simply put a 3 here to ensure the equation is balanced. And sorry, this is supposed not to be a 3, because these ones are 2. So I put a 3, and here I put a 2. Sorry, a 2. I'm supposed to put a 2. Yeah. So that one is balanced as that. Then I can do a group 3 aluminum nitride. In group 3 I always like aluminum, so I'm having Al solid plus N 3 minus. Then what are we going to form? I'm going to form a substitution where I'm having ALN, because this one has 3, aluminum is 2 to 8 to 3, so plus 3 minus 3 is equal to 0. Then I'm going to have this at the end of the day, based on trivalent radical nitride reacting with the different elements from group 1, group 2 and group 3. Then you'll see how those substances or the different products are formed. That's what we are going to have at the end of the day. Now, the last one that I'm going to talk about is under trivalent radicals is phosphate. The last one is phosphate, and phosphate is a very nice compound, and it is found in so many areas, and we use them in very variety of ways in life. So it is a phosphate. Phosphate is a trivalent radical, and we write it as PO4 minus. This is a phosphate. Mostly it exists as an acid. Majorly the ones that I've seen and I've interacted with is just an acid, where when hydrogen, a group 1, reacts with phosphate, we form H3PO4. So this is always an acid. It is an acid. So when this reaction occurs, we form an acid mostly. But in other words, it can even react with certain group 1 elements, Li solid plus PO4 minus. What are we going to form? I'm going to form Li3PO4. Then this is now what we call lithium phosphate. Then we balance it because this acquires. Then how can we balance it? I simply put a 3 here. And also there, I simply have to put a 3 here to ensure that it is balanced. Then I can take a group 2 magnesium solid reacting with phosphate as a radical. Then what am I going to form at the end of the day? I'm going to form Mg. Then it picks a 3 from phosphate. This 3 will come down here, and a 2 here will go here. Then now I'm going to have G3 into bracket PO4, 4. Then I'm having a 2. That's magnesium phosphate. Then how do I balance it? Magnesium is a 3. Then I put a 3 here. After putting a 3, phosphates are 2. I simply put a 2 here. Then to balance that. Then I can have aluminium, my famous and known group 3 metal that I use here. PO4 minus. What will happen? Plus 3 minus 3 is 0. AlPO4. Then at the end of the day, I have my aluminum phosphate balanced. Thank you very much. That's what I wanted to discuss as far as radicals, and also radicals can be used in writing advanced type of chemical reaction and balancing them. Now, the last stage that I wanted to talk about is a situation whereby we can have certain compounds containing certain things reacting. For example, I want to pick examples. I'm going to take sulfate, nitrate in group. In bivalent, I'm going to pick sulfate. In monovalent, I'm going to pick monovalent. I'm going to pick nitrate. And in trivalent or those of valence 3, I'm going to pick PO4 minus. All these can react with hydrogen. So when this one reacts with the hydrogen, is H positive plus SO4 minus. It is going to form H2SO4. This is sulfuric 6 acid. Sulfuric 6 acid. I can also have H plus, right, reacting with NO3 minus. Then what am I going to form? I'm going to form HNO3. This is nitric 5 acid. Nitric 5 acid. Or the one that other people call it nitric acid. To balance this, I'll simply put a 2. Then that one is not, there's no need. Then the phosphate one I already discussed, where we are going to have H plus PO4 3 minus. Then I'm going to have H3PO4, which is phosphoric acid. Phosphoric acid. Then we've realized that several radicals, certain radicals, when they react with the hydrogen, they give us various types of acids, that we use in life. Thank you. That's what I wanted to discuss as far as advanced writing and balancing chemical equations are concerned. Let us meet in the next video. Have a good day.